Good afternoon to everyone. Today we are going to learn about germanium. That means we will study different properties, isotopes, basic idea, occurrence, compounds of germanium, chemical properties of germanium, and lastly we will see why we are going to study germanium. That means what are the applications of germanium. We are learning some idea regarding the semiconductor in this chapter. And the name of the chapter is classification of elements, but as you are computer engineer, so we are going to learn something what would be very influential or important to uh, construct some electronic devices. So we are going to focus. We may have studied some other, we have lot of other chemicals or other elements, but we are not going to focus on that because we have some target that we want to give preference or precedence to some specific elements that can be helpful to you in future. So we are going to learn about some semiconducting materials that can be used to prepare different types of semiconducting devices, LEDs, or different types of instruments or parts of instruments. Okay, then let's start the study of germanium. First of all, we will like to learn about the basic idea of germanium. Germanium, the symbol is Ge. It has the atomic number 32 and the atomic mass is 72.59. As it has the atomic number 32, so you can easily understand the electronic configuration. So we know the electronic configuration comes like this way: 1s2, 2s2, 3s2, 2s2, 2p6, 3s2, 3p6, 3d10, like this way. So just put all the electrons in the orbitals and we will find the electronic configuration for germanium like this. Argon, that means argon means it has the electronic configuration of a full octet: 1s2, 2s2, 2p6, 3s2, 3p6. This is the electronic configuration of argon. So we are not going to write down so big letters or big numbers. Just we are going to precisely, or we are going to compress the name or electronic configuration. Just we put argon in between the square bracket and then just we are giving some electrons in the outside which is different from the inner shell. So the electronic configuration of argon is 3d10, 4s2, 4p2. So this is 18 and then 10, 18, 10, 28, 30, 32. So this is the electronic configuration of germanium. It is lustrous, hard, brittle, grayish white metalloid in the group 14 or group 4A. So you can see it looks little bit dark. However, it has some brightness, bright part also. But depending on the capturing capacity of the camera, so that can give you the different types of brightness. However, it looks like little bit bright or hard, and also this is a hard brittle grayish white metalloid. The properties of that element, it seems to be the property is like as a semi-metal. That means it can show some metallic character or some non-metallic character or in between metal and non-metal. So we can consider this is as an metalloid. So metalloid in the group 14 or group 4A. So melting point and boiling point are quite high. So melting point is around 1211.4 degree Kelvin and the boiling point is 3106 degree Kelvin. So this is quite large or quite high, the melting and boiling points. We also have seen for some other non-metals like a silicon and also boron. We have seen the melting and boiling point of that elements are also very high. So most of the case the melting and boiling point of some non-metals or semiconductor, these are very high, and among them the boron is the most having the maximum melting and boiling points. Density near room temperature, that means at room temperature, that means 25 degrees Celsius or 298 Kelvin. At this temperature the density of the germanium is around 5.323 gram per cm cube. Gram per cm cube, that means this is 5.32 times heavier than water. So if you take a small chunk of the germanium and try to put over water, it will immediately go into underwater. So the density of germanium is 5.32 times more than water. Chemically similar to its group neighbors, that means germanium is in the same group of carbon or silicon or tin or same group. So their chemical properties are almost metalloid, and the chemical properties of this germanium are very similar to silicon or the below one, tin. So you can consider the chemical property of that element are very similar. Pure germanium is a semiconductor. We are going to learn this element just for this property, because pure germanium is a semiconductor or with an appearance similar to elemental silicon. So pure silicon also an semiconductor. By inserting some impure substance, by inserting some doping substance, sometime we can call it as poison or dopant. So by inserting that types of chemicals or some compounds at a fixed or certain ratio, we can increase the conductivity of that pure semiconductor. So we can use these types of germanium to make some semiconducting devices. Occurrence in nature, where we can find the germanium. Actually this germanium is not very much available in the earth crust. This is only 7 parts per million in the earth crust. You can have only 7 parts per million. And another very important thing, that can be in the third from the bottom. That means based on the availability in the nature or earth crust, if you list all the elements in the periodic table, you can have the germanium at the bottom, third from the bottom. That means if you organize from the top, and then the list is the germanium in the position third position from the bottom. So that means this is not very much available in the nature or in the earth crust. I have mentioned one term, 7 parts per million. Anyone have the idea what is the parts per million? Do you know? Anyone?
No, sir.
Parts per million, this is a unit, or this is an expression in two different components. It can be solid, or it can be liquid, or it can be in gaseous. So if you have some components like as salt and sand, if you have 1 million kg of the mixture, if you have a mixture of 1 million kilogram, and if you have 1 kg of the salt and rest of the sand, then you can consider that mixture is 1 parts per million. That means the total volume is million. And what are the components? That means I have mentioned salt would be only 1 kg in 1 million kg. So what are the part of one component? So germanium, if we consider the total earth crust as 1 million division, then you have only 7 parts in the 1 million parts of the Earth's crust. So 7 parts per million, that the abundance of the germanium in the Earth's crust is estimated to about 7 parts per million. That places in the bottom third of the elements arranged according to their abundance. So, as already I have mentioned, that if you organize all the elements in the periodic table according to their availability in the Earth's crust, then you can find out germanium at the third position from the bottom. So it means the abundance of the germanium is very less in the nature. The two most common minerals of germanium are argyrodite, argyrodite and germanite. So there are two different types of mineral, two different types of compounds. Argyrodite is the mineral in which Winkler first discovered germanium. So in this compound, this is the name of a scientist. He has invented germanium in argyrodite compound first discovered, but germanite contains about 8% of germanium. But this compound germanite has little bit more percentage. It has been mentioned only for a specific compound. So in germanite compound about 8% of germanium is there. Most germanium today is obtained from zinc ores. We have several zinc ores, zinc blend or different types of zinc ore, that means zinc sulfide or something like this. So nowadays, how much germanium we obtain from the nature? We get mostly from the zinc ores. When those ores are treated with to obtain zinc metal, some germanium is produced at the same time. That means we are getting as a side product or byproduct of that process. When we want to synthesize or we want to get the germanium, we want to get zinc from the ore of the zincs. So most of the time nowadays we are getting the germanium from other process, that means by the synthesis or production of zinc from zinc ores. We have several isotopes of germanium. There are 5 naturally occurring isotopes of germanium. Among them 70, that means mass 70, 72, 73, 74 and 76. These are the mostly common isotopes. As I have mentioned in the first slide that the atomic mass of germanium is 72.59. So actually any element in the periodic table cannot have the atomic mass any decimal number or any fraction, because still we do not have the number for neutron and proton. Just what is the atomic mass? We will consider always the atomic mass is the sum of proton and sum of neutron. So we cannot have any fraction for the atomic mass. However, we are getting the atomic mass for germanium is 72.59. This is found from the atomic mass of that specific isotope multiplied by the relative abundance in the nature, and after averaging of that multiplication, then we are getting the fractions. So we have 5 different types of isotopes with 70, that means atomic mass 70, 72, 73, 74 and 76. So here you can see we do not have any fractions, because we have mentioned that atomic mass is the summation of number of neutron and number of proton. So always the atomic mass of that specific element should be a whole number, no fraction. Germanium 76 is slightly radioactive. That means you are familiar with the radioactivity. So germanium 76 is slightly radioactive, not very often or not severely, and this is the least common. That means anything in the nature, if it is radioactive, it easily converts to some other elements, and the availability of that element is very less. So germanium 76 is slightly radioactive, so it can convert into other elements or other isotopes. So it is not available very well or not too much. So germanium 74 is the most common isotope. So first one, or that means what I have mentioned, germanium 76 is little bit radioactive, so that we cannot have in the nature very often. And germanium 74, this is the maximum abundance. That means we have 5 different isotopes. However, the mostly available germanium or isotope of germanium is 74. So natural abundance of the in between these 5, so germanium 74 is mostly available. It is possible to buy germanium that is 99.9999%. So you can get very pure germanium, and this pure germanium is needed to prepare a semiconducting device, because if there is something impure inside your semiconductor, then the conductivity will be changed what you do not want. Sometimes you are generating a device what needs a specific amount of conductivity, but if it conducts more than that, the device can be destroyed or it can catch fire, or even it may have some impurity that do not supply or do not allow to conduct electricity. In that case, you may not get the device to work at all. So you need to have very pure semiconducting material, and then you need to add a precise amount of the impurity or N type or P type semiconducting element or compound. This level of purity is needed in order to use the material in the production of semiconductors. So if you do not have very high quality or highly pure semiconducting material like that means germanium or silicon, then you cannot prepare a good quality semiconductors. Compounds of germanium. Actually, we do not have so many compounds of germanium. There are two forms of oxides of germanium. Germanium 4, that means germanium oxide dioxide, this is GeO2, germanium dioxide, and germanium monoxide. That means here the oxidation state of germanium is 4 and the oxidation of germanium here is 2. So there are mainly two forms of oxides or two forms of compounds are found for germanium. By roasting germanium sulfide, that means we have some other compound. That means normally when we are getting germanium from the zinc sulfide, in that case we may get germanium as zinc sulfide, sorry, germanium sulfide. So if you have germanium sulfide, you can burn germanium sulfide in air, that means with oxygen. So if I ask you for any reaction, that means a reaction with oxygen or reaction with air or roasting or combustion, everything is same what I am mentioning, that roasting with air or roasting or combustion or reaction with oxygen, all are same. So if you burn germanium sulfide in the air, you will get germanium dioxide. So like as carbon, it will form as carbon dioxide. Here we are getting germanium dioxide. Similarly, how we can get the germanium oxide? You know how we can form the carbon monoxide. carbon monoxide is formed when carbon dioxide reacts with further carbon, then it gets the carbon monoxide. That means incomplete combustion of carbon can form the carbon monoxide. So similar, the reaction of the germanium is very similar to carbon, and we are getting germanium dioxide and germanium monoxide. So germanium monoxide can be obtained by the high temperature reaction of germanium dioxide. That means when we are getting germanium dioxide or carbon dioxide, that means for if we want to get the carbon monoxide, then you can react carbon dioxide with more carbon, then it can form carbon monoxide. So in case of germanium monoxide, you can burn or you can react the germanium dioxide with germanium metal. So in that case you can get the germanium oxide. Germanium dioxide has the unusual property of refractive index that is very precise, and this is very costly. Germanium dioxide has unusual property of refractive index. Normally you may know that the refractive index of glass, different types of glass material have the refractive index around 1.5 or something, or 1.41, 1.5, 1.52, like this. But germanium dioxide, that means if you have a germanium dioxide component or compound, in that case the refractive index, do you know what is the refractive index? You have learnt in the SSC and HSC. Refractive index, anyone? Maybe you have forgotten. The refractive index is the refractive index when one light comes or when one light passes through two different mediums, like as the light coming through the air, and if it passes through a glass, so in between the plane of the two different medium, so first the light is coming through the air and then it is passing through the glass. So here two different medium, so the light do not go directly or directly to through the second medium, either it will go little bit far away or little bit far away from the perpendicular line, or little bit closer to the perpendicular line. That means the direction of the light do not remain same after passing the light from for two different mediums. So the refractive index is that the ratio of the incident angle and sine of the incident angle and the sine of the refractive angle. This is known as the refractive index. That means if there are two different mediums and light passes through the two different mediums, then the light do not go or do not pass in the exact same direction, therefore the light changes its direction. That is the incidence. That incidence is known as refractive index, refraction. So that is known the refraction. So the ratio of sine x, that means the ratio of sine I or incident angle and the ratio of sine r or the refractive angle is known as the refractive index. Chemical properties of germanium. Already I have mentioned about the compounds of germanium. So okay, one thing what I didn't mention, the germanium dioxide has the unusual property of refractive index. So having the unusual refractive index for light but transparency to infrared light. So in different types of instrument, as I have used the infrared light, infrared light, maybe in the last class I have mentioned about the infrared light. That means in case of vacuum, whatever what I have mentioned in the to heat the food we use microwave.
Oven,
Microwave,
sir.
yes, microwave. So in case of microwave, we have mentioned that we produce some light, infrared light. So transparency to infrared light, that means as the refractive index of that germanium oxide is very different or very high, and it can pass the infrared light. Therefore, these types of materials are used to prepare different types of optics, what are very useful to perform some experiments with the infrared light. So we are purchasing these types of mm, materials or optics, maybe just one material or one glass, just 1 inch diameter, 1 inch diameter, and maybe few millimeter, 5 or 6 millimeter diameter thickness. Just can you imagine, very small amount, 1 inch diameter and 5 millimeter or 6 millimeter diameter, these types of one crystal or one optics, if we want to purchase, we may need more than $1,000. That is so expensive. So that is because for working with the infrared light, you must need to use these types of optics. Otherwise, if we use different types of optics like a silica glass or any other types of pyrex glass, the infrared light cannot pass through this. So we need to use these types of germanium dioxide, these types of material. So that material is not very much available, so we need to spend a lot of money to purchase these types of optics. So let's see the chemical properties of
Sir,
germanium. Yes.
why this is unusual property? Because of it's expensive.
No. Unusual, due to unusual property, we can use these types of optics for some special purpose. No other element can give these types of property. Therefore,
Oh, okay, this
we
is
need
just
to,
special.
yeah,
Okay, okay.
they're very special. No other elements have these types of property. So we, if we want to work on this field, we must need to use these types of element. So we need to use this and we need to purchase, and as this is not available very much, if we want to use the silicon, so silicon is very available. You can get it from silicon dioxide or silica or many other things. So this is very much available. So the cost of silica is very less, and cost of germanium or germanium dioxide, this is very high. So chemical properties, at normal room temperature it do not very reactive, or it is not very reactive. At temperature above 250 degrees Celsius or at 250 degrees Celsius, germanium slowly oxidizes to germanium oxide or germanium dioxide. That means if you heat or if you burn in oxygen, then you can get the germanium dioxide above 250 degrees Celsius. Normally, to cook, we can heat the food up to 100 degrees Celsius. So that is not enough to get the germanium oxide. So we need to heat up more than 250 degrees Celsius or around 250 degrees Celsius, and at this temperature the reaction is very slow. So if you want to have a vigorous reaction or if you want to have very fast reaction, in that case you need to raise the temperature above 250 degrees Celsius. Germanium dissolves slowly in concentrated sulfuric acid. That is another mention, that many compounds or elements reacts vigorously with concentrated sulfuric acid. That means if the element or metal is quite reactive, in that case it reacts vigorously with concentrated sulfuric acid. However, the germanium is very less reactive, therefore it do not react vigorously. It reacts very slowly with concentrated sulfuric acid and is insoluble in diluted acids and alkalis. That means it do not have any effect on the dilute acids or alkalis. So if you put some concentrated sulfuric acid, that means very powerful acid, in that case you may have some reaction, or it can dissolve, or it can react with the sulfuric acid, concentrated sulfuric acid, but it do not react with dilute or dilute alkalis or acids. It will react violently with molten alkalis to produce germanium trioxide ion. So molten, that means if the concentrated alkali is in molten state, that means the concentration, that means here I have mentioned the diluted acid or alkalis, but molten alkalis and diluted alkalis are different. Diluted alkalis, that means more amount of water, but molten alkali, that means the concentrated alkali with less amount of water, but molten, that means it is just only in liquid state, just it is melted with higher temperature. So the temperature of the alkali is little high and the concentration of the alkali is very high, so that it reacts violently to produce germanium trioxide 2 ion. The common oxidation state, already I have mentioned in the oxide, germanium 2 oxide and germanium 4 oxide, that means germanium dioxide and germanium monoxide. So the common oxidation state of germanium is +4 and +2. Here we have shown this is the +4 and +2, but sometime we may have the oxidation state +3 or +1 or even -4. That also possible, but not very often. So we are not going to show you the compounds or where we can get the germanium oxidation state +3 or +1 or -4. So just we can consider the oxidation state of germanium oxide or germanium monoxide. So the oxidation state of germanium can be mostly +4 or +2. Okay, now the final slide. What are the applications of germanium? We can use germanium as silicon, but due to the availability of silicon, we use silicon very often instead of germanium, because as already I have mentioned, the availability of germanium is very less, and in the periodic table if we organize the elements according to their abundance, then it will be in the bottom 3 and the third position from the bottom. So this is a very rare element in the earth crust, so this is not very much available, therefore it is not very, though it can be used, but being very expensive we cannot use. So if you want to use any semiconducting device with the germanium and you want to use in your electronic devices like some USB drive, pen drive or some other microchips, so in that case that will be very expensive. So you cannot earn that much amount of money after selling that devices. So you can use silicon so that you can get more benefit, or you can spend a lot less money and you can get more customer, so you can purchase or you can have lot of monies. So like silicon, germanium is used in the manufacture of semiconductor devices. We can use, so germanium is used mainly for fiber optics. So fiber optics, are you familiar with the fiber optics? What is the fiber optic? Optical fiber. Have you ever heard the name?
Yes, sir. A way
Then,
to transfer data.
yes, that types of fiber. So that types of fibers can be created, or the germanium is used to prepare these types of optical fiber or fiber optics. And infrared optics, as already I have mentioned in the previous slide, that germanium oxides can be used to prepare the infrared optics. I have used these types of optics for all over my research area, because I have worked every time. All of my research articles are based on these types of infrared research or results. So I have to use always the germanium optics. So it is also used for polymerization catalyst. That is one of the very important use for any reaction. If you need to use some catalyst, if you can use some catalyst, then you can get lot of products with very short time. That means the catalyst can increase the rate of the reaction. So if it is expensive, still then we should use, because we can get the product with the very short time. So if we can use the germanium, it is also used for polymerization catalyst. That means in some reaction where a polymer can form from some monomer compounds, then we can get the polymerization. So we can use germanium for some catalytic reactions, some electronics and phosphors. Another term, phosphor. Are you familiar with the word the phosphor? Not the phosphorus. The term phosphor. Have you ever heard the word fluorescence? Sometime you will find some material. If you put the material inside dark, it automatically glows. Have you ever seen or have you ever heard that types of elements or some substance?
No, sir.
Some elements who has some capacity, if you put some heat or some energy inside that material, then if you put it inside the dark, it will automatically glow some light. That is the characteristics of that element, which is known as fluorescence or phosphorescence. That means automatically it will generate some light. So that are known as phosphor or fluorescence. Phosphors or fluorescence. So to prepare some phosphor or fluorescence material, you can use the germanium. So metallurgy and chemotherapy. You are very familiar with the word chemotherapy. If some of us have some excessive cell division, that means the cancer. Cancer is nothing but the uncontrolled division of cell. We have different types of cell in our body, different parts of cell. So we have millions of cells, and all the cells are getting division, mitosis, meiosis or amitosis, three different types of divisions. So if there is no control over the division of the cells, then we can have the cancer. That means if some portion of the body is have the uncontrolled division of the cells, then the cell will get some extra area which can be considered like a tumor, and these tumors are known as cancer. So if you want to treat the cancer, you need to have the chemotherapy, and these types of germanium elements can be used to generate the chemotherapeutic elements. So that are also even more expensive. So because germanium dioxide have a high index of refraction and low optical dispersion, it is useful for wide angle camera. So if you have some camera lens, sometime we may have maybe 18 to 135. This is the normal the focusing lens length of the lens. Or if you want to take the photo of a room. You may have many of your family or friends, so that you can take the photo. You are inside a room, so you need to take the photo just in a short area or short region, but you have to take the wide region. In that case, you cannot capture the whole picture at a time. So in that case, you need to have some lens with the wide angle camera lens, and that is very expensive. Normally, those who are taking the photo, just very close photo, they use these types of the wide angle lens. But normally those who are not professional, they can take just on an average. But to get the very we have different types of lens category. So just for taking the close photo or for a wide area, you need to have the wide angle camera lens. So to prepare these types of lens, you need to use germanium or germanium dioxide. As stated before, it is an important semiconductor, so it is used in transistors. So that is also useful, but not too many, because the expensive character the germanium is very expensive. So if we want to make any transistor out of germanium, that will be very expensive. So that may not be very good idea, because if you want to make a transistor out of that germanium, you may need to sell very high price. That may not be possible. So we can use, but that is not a good idea. So this is the end of today's class. If you have any question or comment regarding this, then you are welcome.